Hello students, welcome back to my YouTube channel Mathematical Lens by Ganitha. In this video, we are going to continue with chapter number 1, a square and a cube of grade 8 mathematics of the new NCERT text, that is Ganitha Prakash, which is newly launched. Okay, so perfect square and odd numbers. So in this video, we are going to relate how the square numbers with the odd numbers, how are they related, what is the relationship between them. So let us see the difference between consecutive square numbers. Like first square number is 1 and second square number is 4. Okay, so if we see the difference, 4 minus 1 is 3. Okay, these are the square numbers. Let me write down so that you can just recollect. These are the square numbers in consecution. Okay, so 4 minus 1 is 3, 9 minus 4 is 5, then 16 minus 9 is 7, and 25 minus 6 is 9. We are subtracting the consecutive square numbers. So what are we getting? See the answer, observe the answer. This is 3, 5, 7, 9. We are getting all odd numbers, right? So if we continue if this pattern continues for the next few square numbers, so let us see here. We can check for more. Like if we take 36 minus 25, so you get 11. Next square number is 49. So if we subtract 49 minus 36, you get 13, right? So we are getting all odd numbers. So from this, we observe that adding consecutive odd numbers, now we are going the other way now. Starting from 1 gives consecutive square numbers. Here what we did, we subtracted square numbers and we got odd numbers. Now we add the odd numbers and we get the square numbers. So 1 is the first one, so it remains 1. Then we add the next number, 1 plus 3, we get 4. 1 plus 3 plus 5, we get 9. Okay, so first 3 odd numbers if you add, you get 3 square. First 2 odd number, 2 square, that is 4. 1 square, 1. First 4 odd numbers if you add, then 16, that is 4 square. Then first 5 odd number is 25, so 5 square. First 6 odd numbers, that is 36, 6 square, right? So why does this happen? Let us see through this pattern. Like this is 1 dot. If you add 3 dots here, 1 plus 3, you get a square. A square is being formed over here, right? Similarly, 1 plus 3 and then you are adding 5 dots. So you are getting another square. You add 7 dots, another square. So this L shape which is shown, it is showing the odd numbers being added, and then you get square number, the subsequent square numbers. Right? So actually if you are asked any sum of odd numbers, sum of like first, here we derive this, that first 3 odd numbers, then it is 3 square. So if it is asked sum of first 10 odd numbers, so that will be 10 square, which is 100. So without actual addition, you can find out the sum of any odd numbers in sequence. Like suppose it is asked first 20 odd numbers. So 20 square is 400. So whatever first odd 10 number, 20, 100 odd numbers, you can easily find out the sum after understanding this pattern. Okay. So you need to remember this. This is very useful in many competitive exams. They ask such questions, sum of first 10 odd numbers, sum of first 100 odd numbers. Suppose it is 100 odd numbers. So 100 odd numbers means 100 squares. So I told you earlier also 2 zeros means in square it will have 4 zeros. So you'll get 10,000. You did not do the addition. It's not possible, right? So if you remember this fact, then you can easily find out. Now, those who have studied this book, grade 6 book, the new NCERT Ganitha Prakash, The picture below explains why each subsequent inverted L gives the next odd number. So here if we see 1 plus 3, okay, gives you 4. Then 1 plus 3. And then another L is there, 3. And then to make it square, we need to add 2. So 1 plus 3 and plus 2. So this 3 plus 2 is 5. So actually we are adding 1 plus 3 plus 5. The first 3 odd numbers. Okay, this one. This is explained. Similarly here 1 plus 3 plus 5. Then if we take 5 and we add 2 means 7. So you get 1 plus 3 plus 5 plus 7. So we see that the sum of first n odd numbers is n square. Alternative, this is what I explained over here. First n odd number is n square. So whatever n is there, you can just find out first 6 odd numbers. So the sum will be 6 square, that is 36. First 7 odd numbers. So 7 square is 49, right? So you can write any sum if you know the square of that number. Even if you don't know the square, you can find out the square. But you can easily find out the sum without actual addition, right? Alternatively, every square number is a sum of successive odd numbers starting from 1. That is what we saw. Like 1 is 1, 1 plus 3 is 4. So this fact also 1 plus 3 plus 4, 5 will give you 9, right? So this fact also will be useful to decide whether a number is a perfect square or not. Let us see that further. So here it is written that in mathematics sometimes arguments and reasoning can be presented without any words. So you can see here through picture a visual proof is given in through these pictures, visual representation. You can easily understand how the odd numbers add and we get a square number, right? There is no need to explain anything. You can just see the square being formed, right? Now, the fact which we just saw, that sum of successive odd numbers gives you a square number. That fact, this fact we will use to check whether a number is a perfect square or not. Like here, they have taken an example of 25. So 25 minus 1. So first we subtract the first odd number. We get 24. Then the next odd number we subtract. We get 21. Then the third odd number you subtract. So you have to go on doing till you get 0. So 21 minus 5 is 16. 16 minus 7. 7 is the next odd number. These are the odd numbers which are being subtracted. So you get 9. And next odd number is 9. So 9 minus 9 is 0. So you have to go on doing till you get 0. And if you get 0 means it is a perfect square. And since we subtracted first 5 odd numbers, so this is 5 square, right? So this is just the other way around. Like we add the first 5 odd numbers, you get 25. And subsequently, if you subtract one odd number, you get 0, which proves that it is a perfect square. Understood? So you can check with any number whether it's a perfect square or not. Right? Suppose we take a number 20. Let us take some example. So 20 minus 1 gives you 19. Then we subtract the next odd number, that is 3. So you get 16. 16 minus 5, next odd number, gives you 11. 11 minus 7 gives you 4. Next is 11 minus 9. Now this you get a negative number. You are not getting 0. So 20 is not a perfect square. So this can help you in deciding whether a number is a perfect square or not. Right? So this is one technique to decide whether a number is a perfect square or not. We'll see more examples also. Now using the pattern above, find 36 square. Now see, we understood that if we add the subsequent odd numbers, we get that square number, like 35 square. If it is given that 35 square is 1225. And if you add the next odd number to it, you will get the 36 square, right? But how to know which is the 36th odd number? right? Initially, if the numbers are small, you can count and find out. But how do we find out 36th odd number? So for that also there is a technique. So how do we find out the 36th odd number? So like first odd number is 1, second odd number is 3, third odd number is 5, sixth odd number is 11. So if you see a pattern over here, what is double of 6? 12. 6, if we see, 6 into 2 is 12, minus 1, 11. So sixth odd number is 1 less than its double, right? So if we derive the formula like n, if you take the nth odd number, so just double it and subtract 1. So you get the formula as 2n minus 1. So if you want 36th odd number, so you double 36 minus 1. So double of 36 is 72 minus 1 is 71, right? So you got 71, and now 35 square was 1225. So if you add 71 to it, you get the next square, that is 36 square, 1296, right? So this formula is very important. You should remember how to find out odd number, nth odd number. And this way you can find out any square. If you know one of the square, you can find out its consecutive squares very easily. So let us use the combination of both the tricks and find out some square numbers without actually multiplying, right? So suppose the squaring numbers ending with 5 is very easy. So like 20, we'll take a simple number first, then you can explore with other examples. So 25 square, if the if the number is ending with 5, so 5 square is 25, and 2 into 3, multiply the first tens place with the next digit. So 2 3s are 6, so you get 25 square. So squaring numbers ending with 5 is very easy. This is the trick you can apply and you get the square of 25. And you are asked 26 square, right? So you can add the 26th odd number to it. So how to find out 26th odd number? 2n minus 1. So 2 into 26 minus 1. So 2 into 26 is 52 minus 1. So you get 51. So without actually multiplying 26, you can simply add 51 to this and you get 676. 26 square is 676. This you can check in the table which is given above. So I've taken simple number to explain, but combination of these two facts, that sum of the odd numbers gives you the square number, and how to find out the nth odd number. Both the things you apply and you can find out square of numbers, right? Now let us see further what is given. Here they have given example of the same thing which we subsequent subtraction of odd numbers to check whether it is a square number or not. So 38 is the example given. We took one example of 20, we checked that. So here another example, 38 minus 1 is 37. 37 minus 3, just check that they are subtracting odd numbers, subsequent odd numbers. So 34, then you subtract 5, so you get 29. Then you subtract 7, you get 22. And subtract 9, so you get 13. Subtract 11, so you get 2. Subtract 13, minus 1. So you are not getting 0. So it's not a square number, right? It is a very small number, so we already know that 38 is not a square number. But this is a technique to find out whether it's a square number or not. So this shows that 38 cannot be expressed as a sum of consecutive odd numbers starting with 1. Now, so we can say that a natural number is not a perfect square if it cannot be expressed as a sum of consecutive odd numbers. We just saw through example of 38, and earlier we saw example of 20. Now this we can use to find out whether a natural number is a perfect square. Now another question is there. Find out how many numbers lie between two consecutive perfect squares. do you notice a pattern? Right? So let us see, explore this. How many numbers lie between two consecutive perfect squares? So, like if we see 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 24. So let us see how many numbers lie between this. If we see between 1 and 4, there are only two numbers, 2 and 3. Right? You don't have to count 1 and 4. You have to count only the numbers between. So between 4 and 5, 4 and 9. So 5, 6, 7, 8. That means total 4. Right? Between 4 and 9 if we count. So which are the numbers? 5, 6, 7 and 8. There are 4 numbers. So I've written 4. Similarly after 9 to 16. So 10, 11, 12, 13, 14, 15. So how many are there? 6. 1, 2, 3, 4, 5, 6. So 6 numbers. Right? So then after 16, between 16 and 25 if we count. So 17, 18, 19, 20, 21, 22, 23. There are 8 numbers lying between two square numbers. Right? So there is no need to count how many numbers lie between two square numbers. There is a formula for that. If you observe the pattern over here, if you see between 1 and 2, all are, first of all are even numbers, 2, 4, 6, 8. So between square of 1 and square of 2, there are 2. Between square of 2 and between square of 3, there are 4. So if we take like suppose 2 square and 3 square. So which is the smaller number out of this is 2. So just double it. 2 2s are 4. That will give you how many numbers lie between the two squares. Suppose if we take 4 square and 5 square. So which is the smaller number is 4. So what is double of 4 is 4 2s are 8. So there will be 8 numbers. You have to see the smaller number and just double it. So you'll get how many numbers lie between the two square numbers. Right? So we can just derive the answer that number of natural numbers between consecutive perfect square. They should be consecutive, that is important. Consecutive perfect square consecutive if we take in terms of n. So n square and n plus 1 square. Is 2n. 2n. If you don't remember the statement, just remember that whichever are the two perfect square numbers, take the smaller one and double it. Okay? Suppose again one more example, we'll take 5 square and 6 square. You want to know how many numbers lie between 5 square and 6 square. So out of this 5 is small, so 5 2s are 10. There will be 10 numbers. Okay? So we'll just write down the pattern over here, the answer over here, 2n. Consecutive n and n plus 1. Consecutive numbers means n and n plus 1. So if you want to know the number, you will just apply the formula 2n. Right? I had explained you in detail, but you should remember just 2n. There is another question. How many square numbers are there between 1 and 100? Understand the difference between the two questions. Here, How many numbers between two square numbers was asked. Here, how many square numbers between two natural numbers? Between like 1 and 1 to 100, then 100 and 1 to 200, 200 and 1 to 300, like that. So let us go back to the table which we have written some squares earlier, and then write down this pattern. So let us see how many numbers are there, how many square numbers are there between 1 to 100. First we see 1 to 100. So if we see over here, the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 between 1 to 100. Then they have asked from 101 to 200. So if we see there, 1, 2, 3, 4 are there. Then between 200 and 300, there are only 3. 1, 2, 3. Okay. Then between 300 and 400, so 1, 2, 3. So 10, then comes 4, then 3, then again 3. Then between 400 and 1 to 500, there are only 2. Okay. Then again 2. Again 2. Again 2. Right. Then between, this is only 1. 841, between 800, 1 to 900. If we take, if we consider 9 there, so there are 2. Okay, 900 we count with this. So what is the pattern? If you see, then this is 4, 3, 3, and here there were 10. So 10, 4, 3, 3, 2, 2, again 2, again 2, again 2. Then they have also asked between 900, 1 to 1000. So here it is 30 square is 900. So if we take 31 square, if you do, it is 961. And 32 square, if you do, it will be more than 1000, 1024. So there is only one number in that sequence. Okay, so we'll just fill that table. Come back to the question and let us fill in about the information which we just collected. So we saw between 1 to 100 there are 10. Then 101 to 200 there are 4. 201 to 300 there are only 3. Similarly here also there are only 3. Then between 401 to 500 there are 2. Again here also 2, 2, 2, 2. You can see that the number are going on reducing. Okay, and between 901 to 1000 we got only one number, which was that 31 square, which is 961. Okay, so see the decreasing order. In the first it is 10, and then it is 4, then 3, 3, then 2, 2, and then it is only 1. Okay. So there is another question asked, what is the largest square number less than 1000? So that also we already found out, 961, 31 square, because if we do 32 square is 1024, which is more than 1000. So this will not come in the answer. So the answer is 961. So let me make it 1. I hope you have learnt and understood a lot of facts about perfect squares and their relationship with odd numbers. And if you remember this pattern, understand the pattern and remember few formulas which we just discovered, then you can answer so many questions without actual addition. And it will really help you in many competitive exams. These questions are asked. So just remember the formulas and enjoy doing maths We just saw the relationship between perfect squares and odd numbers. Now let us see the relationship between perfect squares and triangular numbers. So first let us recollect the triangular numbers which we have learned in grade 6, right? So what were the triangular numbers? They form the shape of a triangle. They can be arranged in the form of a triangle. Like if you see 1 is a square number as well as a triangular number. 3, you can see it is arranged in the form of a triangle. So you can make a triangle out of. So 6, it can be arranged in the form of a triangle. Then next is 10. So it can be arranged in the form of a triangle. Then it is 15. So how these two things are related, perfect square and triangular number, let us see. Again, this is explained very nicely through visualization. But then you don't need any explanation. So just see here. First one. The first two triangular numbers, 1 and 3. So this is 3 and then 1 is added over here. So you get a square number, 4. So 1 plus 3 is equal to 4, which is square of 2. Similarly, you take the next triangular number, 3, and add 6. So 3, 6. We have arranged 6 first and then 3 is arranged over here. So you get a square number. Right? So 3 plus 6 is 9, which is 3 square. Similarly, the next two, 6 plus 10 is 16, which is 4 square. Right? So similarly, you can just write down the next pattern. So next triangular number is 10, and 10 plus 15 gives you 25. 25 square of 5, right? So you can just arrange the numbers. So till here we have covered what are square numbers, their perfect square numbers, how to identify whether a number is a perfect square number, the relationship with odd numbers, also with triangular numbers, right? In the next video we will learn about square roots. Thank you.